Hello, everybody. Welcome to Miss McGuire online lectures. And today we are covering the integumentary system. So let's go ahead and begin. Okay, so integumentary system is made up of cutaneous membrane or your skin. So skin is the organ of the integumentary system. And it's also made of accessory structures such as hair, glands, and nails. So if you look at the skin, there is two main layers of skin, epidermis and dermis. And on this diagram, you see a cube of a skin, and whatever shown in kind of like a light beige color, that represents epidermis. And this pinkish color, that way deeper layer right here, that's a dermis of the skin. There is another layer underneath the dermis that is called hypodermis, or it's also called subcutaneous membrane or superficial fascia. So this is not really part of your skin, but hypodermis shares some functions with dermis. And hypodermis is very vascular structure, mostly fat, right? So again, so epidermis and dermis are part of your skin. Hypodermis is not. So if you look at the major functions of the integumentary system, it would be protection that give you three types of barrier. It's a chemical barrier because your skin has low pH secretion and like an acid and defensins, that is chemicals, that retard bacterial activity, so chemical barrier. Your skin is also biological barrier because you have dendritic cells and macrophages that are part of your immune system. So those are your white blood cells. White blood cells, they can differentiate into different cells like dendritic macrophages. And this protects you from bacterial infection. Your skin also obvious physical and mechanical barrier, like keratin and glycolipids block most water and water-soluble substances from entering your body. And also it's prevent your water loss. So it blocks water from exiting your body as well. And your skin limits penetration. So you have limited penetration of skin by lipid soluble substances, plant resins like poison ivy, organic solvent, salts or heavy metals, and some drugs. So even this lipid soluble substances are easier to penetrate your skin. It still protects you from all these substances. So it doesn't allow them freely move inside your underlying tissues, right? So protection. So again, when we talk about, protection, we have chemical barrier, biological barrier, physical or mechanical barrier. Another function of the integumentary system is body temperature regulation. And you do it by respiration, that is sweating. So about 500 milliliters per day of routine perspiration. Did I say respiration? No, respiration is a, exchange of the gases. Okay, we have lots of respiration, internal, external. So perspiration, that's when you sweating. So, and this is at normal body temperature. So even when your temperature is not increasing, you still have sweat production that cools you down. At elevated temperature, you have dilation of the blood vessels in your skin, and that will increase your sweat glands activity, and it will cool your body even more. Another function of the integumentary system is sensation, and we call it cutaneous sensation. because your skin is cutaneous membrane. So another name for your skin is cutaneous membrane, and we have cutaneous sensation. So you can sense temperature, touch, pain, with those sensors like that located in your skin. Your skin performs metabolic functions such as synthesis of vitamin D precursor, collagenesis, production of collagen, chemical conversion of carcinogens and some hormones. Your integumentary system is also a blood reservoir. Up to 5% of body's blood volume is stored inside those cutaneous blood vessels, and some degree of excretion, because you excrete, so that means you get rid of nitrogenous waste and salt in a sweat. So now we will go at the morphology or structure of your skin, and it will be overview of skin layers. So at the surface of your skin, you have epidermis, and epidermis is made of stratified squamous epithelium, and it's keratinized. That means that a top layer of your epidermis are dead cells, and you have lots of keratin and glycolipids in those upper layers of the skin, right? So how many layers we have? We have 4 or 5 layers, and we have 5 in area where we have thick skin, and it's a palms and soles. So 4 or 5 layers, and we call it thick skin. If it's thin skin, we will have 4 layers. Epidermis is avascular, like epithelial tissue. All epithelial tissue is avascular. The major cells are called keratinocytes, and one of the job of keratinocytes is synthesize protein called keratin. So we will go from deep to superficial. All right, and we're talking again about epidermis, just the upper surface, upper layer of your skin. The one that is made of stratified squamous epithelium keratinite. So if you go deep, so the deepest layer is called stratum basal. I call it basalar because I know that basale is appropriate way to pronounce it. So stratum basalar. So it's one layer of cells. So right here, right on the top of connective tissue. And this is already dermis. So this pink structure over here, this is dermis, and whatever shown in yellow. And remember, those colors just really for representational purpose only. So that's a dermis, and the first layer of epithelial tissue lying on the top of dermis is a stratum basale. So it's a derm layer, means we have mitotically active cells. So cells will divide, right? Grow, divide, and cells kind of will move from this superficial to, from this deep to superficial layers. So they kind of will make their way up to the surface of your skin, and by moving up, they will change and they will start dying. And when they at the very surface, they are dead. Those cells, superficial cells of your skin are dead cells. But again, back to stratum basale, it's a derm layer. We have dermal papillae. So we here, that's a dermal papillae. So they right on the top of it. You will find touch receptors in the stratum basale. The old name is Merkel cell, so you can just call them touch receptors. Also, you will find cells that are called melanocytes. And so this is a Merkel cell. This is a sensory neuron, but here's the cells that represent melanocytes. And melanocytes produce melanin. And melanin will migrate to the upper layers So it will migrate to keratinocytes that is located on the top of stratum basale, and they will form pigment shields for nuclei. So they will protect the nucleus of keratinocytes from UV radiation, because obviously you receive lots of UV radiation from the sun by your skin. So your skin is a barrier also that protects you from UV radiation. And what it can do, it can damage DNA inside those keratinocytes. And when we have plenty of damage in the DNA, it might, you might have damage in a very important genes that are responsible for cell division, and cell might start divide out of control, so you can form a tumor and possibly cancer. So melanocytes doing their job by protecting the nucleus from harmless radiation from the sun. Okay, so now remember, we're moving up. So the next layer is called stratum spinosum. And here we will have keratinocytes that attach to each other by desmosomes. You will find Langerhans cells. Another name for Langerhans cells are just macrophages. So those are white blood cells that can engulf the foreign substances. So that's part of your immunity. So here's the stratum spinosum. So it's several layers of cells. And what happened with these keratinocytes? They start synthesizing lots of proteins. So you will find a bundle of proteins inside this keratinocytes. It's pre-keratin. It's not keratin yet, but that's a protein that will be transformed into keratin. Now, next one is granulosum. So this is the granulosum. If you use a microscope, you really can see this layer pretty good, because you will see there's lots of granules. And those cells are full of protein called keratinohyaline that binds keratin filaments together. And it will have all these granules, lamellar granules with keratinohyaline, and will have this appearance of granular structure. That's why it's called stratum granulosum. So cells are here are already dying cells. So what happened, because they synthesize so many proteins, pre-keratin, keratin, keratinohyaline, so that this bundle of proteins start damaging the cells. So the organelles became to so start breaking apart, right? And cells start pretty much dying. The nucleus, damaged. So the organelles are all falling apart. So the cells are dying over here, and the whole volume of the cell now is occupied by bundles of proteins. And we wanted dead cells on the surface because, if it's already dead, you cannot kill it with some maybe light scratch. So if you, have a light scratch or some impact, or even the sun and the light cannot kill something that's already dead. So it's good to have dead skin on the surface for protection. Living tissue would not be as good to protect you as already, this layers of dying cells or dead cells. And when we start moving further, pretty much already cells are dead. It's just their cell membrane and keratin inside and lipids in between. So stratum granulosum, keratinohyaline, and lots of these granules, lamellar granules. And then we get to stratum lucidum, and stratum lucidum only found in thick skin, and it has a another protein, elidin, that is a transformation product of keratinohyaline. And the most superficial layer is stratum corneum. So stratum corneum, we have dead cells filled with keratin, and it's 15 to 30 layers of cells. And this is the one that you constantly shedding off. So you know, when you sometimes you look at your skin and it look like it's very dry, and you have like flakes of dry old skin. Those are these dead layers of stratum corneum. So you're constantly losing those cells. No wonder, because they are not living cells. So this living stuff cannot be attached to your body for very long period of time. So lots of these cells will be shed off, but you have constantly cells in a stratum basale that constantly divide. So you're replacing them with cells from stratum granulosum, right? So granulosum became corneum, spinosum became granulosum, right? And so on. So it takes about 4 weeks for replacement of your stratum corneum, right? So that means if I have cell over here in the stratum basale, so this cell will be pushed up, right? And it start accumulating keratin, pre-keratin, keratinohyaline, right? And then the all organelles degrade, the nucleus degrade, cells are dying. So pretty much from this cell then dies off and became this dead, pretty much just a membrane filled with proteins, and then you're just losing it, right? You're shedding it all. Okay. So that was epidermis. So let me just go back to tell you guys kind of like, what is that? What are we talking about? So we were talking about this epidermis, just the upper part, right? If you look at histology slide, this will be the one that's shown here kind of like in dark purple color. That's epidermis, but your skin go all the way up to here. So that's a dermis. And now we will look at the dermis of the skin. All right, so here's our dermis. So the dermis itself is made of 2 layers. So the superficial layer is called papillary layer, and then reticular layer. So this papillary, you know, the dermis forms this kind of like hills, like elevations, right? So you see like this elevation, and then we have depression. So it's not straight, it's kind of like a waves. And this part of the dermis that goes up called dermal papilla, and it's formed papillary layer. And this papillary layer, the same as all the dermis, are made of connective tissue. So on the top we have epithelial tissue, and then under epithelial we have connective. Specific connective tissue in papillary layer is areolar connective tissue. The cells that you would find here would be fibroblast mostly, but you do have some adipocytes, you have small blood vessels, and you have Meissner corpuscle, or those you know, touch receptors, very fine touch. So you have this Meissner corpuscles that are touch receptors, excuse me. And the second layer is reticular layer. So you can look over here. And reticular layer is made of, excuse me, dense irregular connective tissue. So areolar connective tissue, dense irregular connective tissue. And if we start from the beginning, epithelial tissue, specifically stratified squamous, epithelial keratinized. So you see this keratin on the top, that's a dead layer of cells. Then areolar, and then dense irregular. And in a dense irregular, layer, you will find fibroblasts as well, because we do need cells that produce all these fibers. And fibers will be collagen and elastin. Okay, so if you look here again, we have epidermis, we have dermis, and then hypodermis. Another name for hypodermis is superficial fascia, subcutaneous tissue. It's the deepest region. It's not technically part of skin, but it shares some functions, right? So it does has blood vessels, it's very vascular, and it provides, some sensation as well, protection. So whatever function of your skins are, hypodermis share most of this function with your dermis. So it's hypodermis is mostly adipose tissue and highly vascularized. Okay, now very quickly about skin pigmentation. So we have 3 pigments: melanin, keratin, and hemoglobin, that affect the color of your skin. The major one, of course, melanin, and this is the one that you synthesize. Melanocytes synthesize it for you. Keratin and hemoglobin. Well, hemoglobin is found in red blood cells, right? So somebody's skin is kind of pinkish, right? So that might be because of the lots of superficial blood vessels, and hemoglobin is pink or red, so that gives us pinkish appearance. Keratin you get from your diet. But the major pigment that affect your skin color is melanin. We do have 2 different forms of melanin. We have eumelanin, and this one is black or brown pigment, and we have pheomelanin. And pheomelanin is more red or yellow pigment. So the people who are red, have red hair and very light skin, they predominantly have this pheomelanin. So more melanin accumulates in your keratinocytes, the darker your skin becomes. So, for example, if you go to a beach very often and you don't use sunscreen, you have your suntan. And suntan is, what is suntan? Well, when you are under a sun, your skin is damaged, your keratinocytes are damaged. So melanocytes start synthesize more melanin, and this melanin moves inside your keratinocytes to protect you from damaging way of UV radiation. So that's why your skin became darker when you are under the sun. So melanin are stored inside melanosomes, and melanosomes are organelles that synthesize and store melanin. And large masses of melanocytes produce moles. So moles are just the whole aggregation of melanocytes, and most of the moles are, absolutely harmless. Some can, however, turn into melanoma, and that would be the cancer of melanocytes. But most of them are just benign. Now, remember that skin is made of cutaneous membrane and accessory structures, and cutaneous membrane is your skin that made of epidermis and dermis, and hypodermis kind of not really part of your skin, but share some functions. And what are those accessory structure? Well, those are gonna be your hair, your nails, the glands, like sweat glands, oil glands, right? So function of, so here we're looking at hair, accessory structure hair, and function is protection, sensory input, thermoregulation, communication. Yeah, you would think like, what kind of communication? Not so much for human, but animals, like, if the hair stands up on your cat, this is a way of communication. This is a way of like, I am big, I am scary, so don't mess with me. So that kind of way of communicate for animals. I don't think people ever use their hair for communication, but animals do. Hair color also depends on amount of melanin and type of melanin present. And if you look at hair structure over here, just very quickly, we have this, what is called a hair bulb. So let's say this, whatever you see kind of like outside of your skin, this is called hair shaft. And whatever is deep in your skin is hair root. Then we have hair bulb, like this thick part on the base of the hair. And the hair is an organ, or well, hair, I would say, hair grows inside the organs that called hair papilla. So you have papilla, that is an organ of integumentary system, and hair grows inside this organ in the papilla, and then on the outside of your body, right on the surface of your body. What we have here is called dermal papilla. And dermal papilla, this is where you have blood supply, nerve supplies, and this is where you bring nutrients to these cells that are also keratinocytes. And those keratinocytes will synthesize keratin, that what your hair is made of, right? So you have hair bulb, and you have dermal papilla, and what is called hair matrix is where those keratinocytes that are active, they divide and they synthesize keratin that make this hair. So your hair is dead stuff, the same as your nails. That's why when you cut your hair, you don't have any painful sensation, you don't bleed, the same as your nails. Now, when hair grows, we have three phases: anagen, catagen, and telogen. So next slide will tell us how it all works. So anagen is a growth phase that about 2 to 8 years, which determines the length of your hair. For some people, the anagen only lasts 2 years, and their hair just doesn't grow very long. For other people, hair can grow very, very long. Then catagen is regression phase, 2 to 4 weeks. And you can see over here that the follicle, right, the hair follicle, decreases in size and detaches from the papilla. Because if you do not have this attachment to papilla, you don't have blood supply. You don't have blood supply, you don't have nutrients, you don't have oxygen, right? So this is where hair pretty much are dying off, right? And telogen is shedding phase from 3 to 5 months. And this is where you shed the old hair and you start, new growth again with the anagen. About 10-15% of your hair is constantly in a shedding phase. So when you're losing your hair, when you wash your hair and you're losing some hair, it's a perfectly normal process. It just when you start losing more, then then you grow, you lose more than you grow, then your hair might get thinner. That's what happened with age, right? Okay. So each hair is in a different phase of the growth cycle at any one time. So they do not grow in unison or shed at the same time. So it's not like your hair grow, then you shed everything off, right? So every single hair in its own phase. That is really fascinating. Okay. Another accessory structure is your nail, and function is protection, a back support for picking up small object. And if you look at the structure of the nail, it has a nail body, right? And it has nail root. And this is where your nail root is. You have your matrix. And those are, again, keratinocytes that produce this keratin. That is a part of your nail. What else? You have also a lunula, there is like white part, whitish part on your nail. And this is because you don't have any blood vessels underneath this part of the nail. That's why it look pale or white, right? Now, epanuchia is the cuticle. So that's pretty much the skin that keeps your nail in place, right? That's what you call cuticle, epanuchia. And you have hypanuchia. This is another fold of the skin that also attaches your nail to your finger. Okay, so that's nails. Glands. So you have several glands. You have sweat glands and you have oil glands. So the sweat glands is shown. Sweat gland is shown over here. And when we talk about sweat glands, we have two types: eccrine and apocrine. So eccrine, this is you pretty much, you know, your whole body is covered by eccrine sweat glands with, you know, very, very few exceptions, but those produce hypotonic sweat. So very low concentration of salt. So it's pretty much watery substances. And the function of eccrine glands is thermoregulation. All over skin surfaces, it has water, salt, antibodies, metabolic waste, some antimicrobial peptides, like dermcidin, right? That's just antimicrobial peptide. So it's mostly watery substances that cools you down. Apocrine sweat glands, they found only in axillary and genital region, and they kind of associated with hair follicles. And those are the ones that give you body odor. And this is more concentrated sweat. And this is not for thermoregulation. This is really to give us this kind of specific smell. So as a species, we can recognize each other, right? If, for example, if you have a dog, you know, your dogs smell other dogs. And where they smell? They smell in this genital region. And so because, and human as well, we have this apocrine sweat glands that produce this body odor. And it's, you know, at some point of time, it was important for, you know, for our survival and reproduction. Now, obviously, we want to get rid of this smell. We use deodorants and so on. But those apocrine sweat glands, we still have them. Another type of glands are oil glands. And oil glands are called sebaceous glands. And by the way, the sweat called sudoriferous gland, and those are sebaceous gland. And they produce sebum, oily substance, for lubrication, antimicrobial properties, and water retention. And sebaceous glands, they are associated, you can see over here, with hair follicles and with your hair. So this is histology slide, and this structure over here, those are sebaceous gland. And this kind of like yellow structure, that's hair. Okay, so we also mentioned that there is a sensory function of your skin. So we have several sensory receptors. We have tactile receptors or Meissner corpuscle. So it's this arrow show us the Meissner corpuscle. We have pacinial corpuscles, not shown here, but they deeper in dermis, and this is vibration sensor. We have Merkel cells that are in epidermis, in the stratum basale, and we have sensory nerve endings in the hair follicle and sensory nerve end. So the hair follicle, so those nerve endings, they feel, you know, vibration of the hair. You also have sensory nerve receptors for pain and temperature in your skin. So your skin provides lots of sensation, right? It's a touch, pressure, a pain, temperature, right? So that's at all these receptors and cells, such as Merkel cells. Now, thermoregulation. So that's also a function of your skin. And you do not regulate it. Your autonomic nervous system, specifically sympathetic nervous system, responsible for thermoregulation. And this is autonomic. That means you don't need to, you don't need to make adjustment. So your, your body will adjust autonomically to changing environment. For example, if outside temperature goes up, you will sweat more, right? Your blood vessels will dilate, but that's all automatically regulated. So sympathetic nervous system monitors body temperature and initiates responses. It will activate your sweat glands and it will increase perspiration. So at normal perspiration, you have 500 milliliters of sweat, but it will be 0.7 to 1.5 liters per hour when they're active. And what happened, if you see here, this is kind of like your skin under normal conditions. So it's nice outside, it's not cold, it's not hot, it's just nice warm weather. So here you have epidermis and you have a dermis. Dermis is vascular. So it shows you some, bigger blood vessels, like maybe bigger arterioles or small arteries, and those are capillaries. And they filled with blood, you can see over here. But if it's hot outside, what do you want to do? You don't want your body temperature to go up. You want to release this heat. And then capillaries, they will dilate. So this is vasodilation. And when blood vessels dilate, right, more blood flowing towards the area, blood brings this heat and you lose this heat. It will evaporate from your surface. All right, so that's, so not only you start sweating, you also became like red or pink, like I do. When I'm in the sun, my face became like so red. And why is that? Because those blood vessels dilate. I have lots of blood flowing to my skin to get rid of this extra heat. So we have arterial dilation, arterial constriction when it's cold outside, or vasoconstriction, vasodilation, right? So that's thermoregulation. We also mentioned that function of your skin is a synthesis of precursor of vitamin D. So you can see it's a pretty complicated process. We're not going into detail, but in your skin, you synthesize this precursor, all right, pre-vitamin D3, and then your liver, your liver and your kidneys will involved in the production of active form of vitamin D. And this gives you some intermediates here, like cholecalciferol, then calcidiol, then we have calcitriol. All right, so those are all kind of like different precursors, and finally you have your vitamin D. And vitamin D is needed for calcium and phosphorus absorption. So if you drink milk, for example, and it has a lot of calcium, they usually add vitamin D in your milk. This way you not only have calcium, but you have vitamin D that allow you to absorb this calcium from your digestive tract to your blood, right? Okay. And the last part of this lecture, we will cover some disorders, some diseases, and injuries of the integumentary system. So the first cancer, and the first cancer of the skin is that we cover here is called basal cell carcinoma. And this is the most common type of cancer, and it's also least dangerous, right? And it affects those cells in the stratum basaler. So it affects mitotically active stem cells. So most common in US, you would find it mostly in the head, neck, arms, and the back. And it can be caused by many things: UV radiation, arsenic, other type of radiation. And yes, it's basal cell carcinoma, so it starts in stratum basale. And here's a picture of it. I like in this picture that you can see lots of blood vessels. You see like lots of blood vessels growing inside this tumor. So that's a tumor. It's a cancerous tumor, but it takes long time to spread, and you know, it's not that aggressive type of cancer. Squamous cell carcinoma affects keratinocytes in so we have stratum basaler, and then we have stratum spinosum. So that affects keratinocyte mostly in the stratum spinosum. And it's if you take 10 skin cancers, this will be 2 out of 10. 2 out of 10 will be squamous cell carcinoma. So this is the second common skin cancer, and this one more aggressive, can metastasize. And it's usually look like a sore that does not heal. So it's constantly, you know, it might heal for a while, then it's, you know, going this raw again. So this is actually patient nose. That's very common appearance for this cancer on the face, on the nose especially. Melanoma. Melanoma is the most aggressive skin cancer, and it affects melanocytes. It might develop from mole, it doesn't have to, but it's most fatal, highly metastasized, and they use what they call ABCD E rule. They added this E recently. So when they look at melanoma, you know, how to distinguish it from a regular mole, it has asymmetry. So it's nice, it's not nice, perfectly like round or oval. So you can see it's really asymmetry. The borders elevated. So usually you have like this borders, this goes up. Then the color, usually several colors. So it's not just one color. It has darker, lighter parts. Diameter is bigger than 5 millimeters. That is about the, if you have a eraser on a pencil, if you have a pencil and you have eraser, so it's bigger than this eraser on a pencil. And it's evolving, so it's changing over time. And additionally, more seriously elevated, firm, or growing. But this ABCDE, asymmetry, borders, color, diameter, and evolving. So that's melanoma. Not necessarily come from a mole, but it might. Eczema. Eczema is actually allergic reaction. It's a dry and inflamed skin. And this is where you produce antibody against either some dust, maybe some mites. It can be also some food allergy that results in the eczema. Some kids might have it, and it might be just temporary, and you know, they get better with time. But sometimes eczema can be, you know, can progress into more serious allergic reactions, even asthma. So it can start with eczema, and then the child you know, develop asthma with time, because it's production of antibodies against harmful harmless stuff like dust, right? You should not have allergic reaction against it, but some people might. Acne. It's in the area of the skin that rich in a sebaceous gland or oil glands, and very common with onset of puberty. So what happened? So you see how here the hair is growing, right? And then that's the hair follicle. And the hair follicle became plugged by some keratin or maybe sebum, and then bacteria start growing. And a very common bacteria is Staphylococcus, for example. And bacteria start growing, it's shown over here, and it causes, of course, inflammation and accumulation of waste product of bacterial metabolism and a sebum as well. So that's acne. Burns. So we have several burns of different degrees: first, second, third, fourth degree. And first degree affects only epidermis and heals on its own. Second degree, then this is where you have blisters, and it affects epidermis and some portion of dermis. Third degree, epidermis and entire dermis, destroys tissue, affects nerve, require medical attention. And fourth degree, when we have even muscles and bones that are damaged. And full thickness burns cannot be repaired by body. So that will require skin graft, all right, and of course medical attention. So that's different degrees of burns. And it's interesting that a second degree, first degree, second degree are very painful, but the third degree and fourth degree sometimes can be painless. So it might, as a patient, might not even feel pain because the nerves are damaged, nerves are destroyed. So you might not, you have a very devastating damage of your skin, but you don't have nerves that would send this pain information to your brain. And on this diagram, if you're in anatomy class, you don't need to know it. If you in physiology class, you do. This is how they estimate the amount of body surface that was damaged by burns, right? So they call it rule of 9, because they pretty much divide your body into regions, like your head, anterior and posterior, both will give you 9%. So 4.5, 4.5. So total 9. Your chest is 9, your abdomen is 9, your legs are both 9, right? And the same on the back. So this guy, you see his back, and this is the front. And then arms, 4.5 anterior and on front, and 4.5 on back. So total will give you 9 anyway, right? So it's kind of like 9, 9, 9, 9, 9 everywhere except of perineum. And this is around your external genitalia and anus, that area called perineum. This is 1%. So total give you 100% of the body. So usually they say like, okay, if the patient has, let's say second degree burn of the chest area, what percentage of body is damaged? So it will be approximately 9%. If the patient has, like third degree damage on the left, arm and forearm and abdomen, then it will be, let's say, only here, maybe only on the anterior side. So that's going to be 9 plus 4.5, so 13.5% of the body approximately was burned, right? So you can, and of course, depends, if this is 9%, you can always divide it into half, will be 4.5, 4.5. So if you know the whole abdomen is 9% and the patient has like a little patch over here that is damaged, you can say, oh, that's approximately 1/4 of the 9. So I hope it makes sense, right? If you know that the whole upper extremity is 4.5%, you can estimate what percentage of skin is damaged. That's called rule of 9. Now we have scars and keloids. So scars, you know, this is your skin that is rich in the collagen. Fibroblast generates scar tissue. So for example, well, if you have a cut in epidermis, epidermis is really good at regenerating. So epidermis will heal very nicely, and you will not be able really to see the difference between your healed part and whatever was there before. But the dermis, when you have damage of the dermis, those keratinocytes start producing collagen fibers, but they don't put them in the right pattern. They kind of randomly put this collagen fiber in a random direction, and this is what scar tissue is. Those are collagen, but in a normal dermis, collagen has a nice pattern of deposition. In the scar tissue, collagen fibers are deposited randomly. That's what makes scar. Keloid scars, like over here, you see keloid scars. This is overproduction of scar tissue. Collagen formation does not stop. And of course, in some people are more susceptible to formation of keloids. Right, so anyway, both scars and keloids are production of scar tissue by fibroblast. A bed sores. Bed sores caused by excessive pressure, common in elderly patients, and they can become fatal if they are infected. So if you go to nursing programs, that's really very important to understand how bed sores are formed. So you can see over here, that's a normal skin, right? So you have bone over here, you have soft tissue like muscles, right? Then you have your skin, right? You have your epidermis, dermis, hypodermis. So, right, you have your hypodermis, you have your fascia, superficial fascia, right? So here we see like bone, soft tissue, and skin. And soft tissue will include your muscles and your connective tissue. And you have blood vessels. Now, when you have constantly pressure, right, to the kind of like specific parts of the body, if the patient are not moving, right? So back of the head, shoulder, elbow, buttocks, a hip, inner knee, heels, right? So those bones start pushing on your soft tissue. And what they do, they pinch off the blood vessels. And if you pinch off the blood vessels, right, then the tissue doesn't get any blood supply. Anything that doesn't get blood supply, the cells start dying pretty much. And cells start dying, they can be infected. And also, because this is a hard surface, so that's a bed. And you also have, you push it against the hard surface. So you have a friction in the skin. So not only you damaging your blood vessels, so you cut off supply of oxygen and nutrients. You also damaging the skin, and you opening up these doors to bacteria and infection that can move up, infect this area, right, and can really even kill a patient. That's why we want to make sure that we constantly, elderly people or people who are paralyzed, we constantly move them, we changing their body position, so to avoid those bed sores that are actually ulcers. Stretch marks happens when dermis is stretched beyond limits of elasticity. So when skin stretched too much, right, and it happened during pregnancy, very often it happened during pregnancy, then we have linear tears. So you see over here, this dark stuff represent collagen. So there is a linear tears in a collagen. And then your fibroblasts start replacing this damaged collagen with pretty much scar tissue. So you heal this area, you heal these tears, but that's what produces stretch mark, right? So there is a healing here, but now you have depression in the skin. And also, some hormones like cortisone can cause stretch marks as well. Right, so that's so you stretch your skin over here, right? You stretch it so much that you break the collagen and elastin. And when collagen and elastin is damaged, when you have a tears, well, it's you will heal, right? But you will not heal perfectly. You will have a scar tissue. Its fibers will not be located in the right, nice, right pattern. Okay, calluses. So here we can kind of compare, like calluses formed when extra stress is experienced. So stratum basalis cells are triggered to divide and increases thickness of the skin. So the calluses over here. So when you have lots of stress, right? If you're walking too much, for example, then you can cause callus. Corns are similar, not the same. They are smaller, round, well-defined, and usually painful when pressed, and caused by pressure and friction, the same as this one. But calluses are larger, more diffused, varies in size, right? So you can see a difference on the picture. And the wart is caused by a virus. So it's also round and diffuse, and so you can also see like there is a little capillaries growing if you have a wart, and they, of course, the cause is very different. That's a virus. And the last slide over here, very quickly, development aspect and specifically old age. And this is, let's read it first. So epidermal replacement slows. So you have epidermis, and remember we said it takes, about 4 weeks for this replacement, but when you get older, it slows down and skin becomes thin, dry, and itchy. Subcutaneous fat and elasticity decreases, leading to cold intolerance, wrinkles. It's also give you increased risk of cancer due to decreased number of melanocytes and dendritic cells. That's what happened with your skin with the old age. Like any organ, your skin is an organ, you need to take care of it, right? So take care of your skin, use sun lotion, use some moisturizing lotion. It's another organ, right? You would take care of your liver, right? You would take care of your kidneys, of your heart. You need to take care of your skin as well. So if you see in a younger skin, in a dermis, we have collagen, we have elastin, and they have a very nice fibers. They pretty much have defined pattern, and with the older age, we have damage of collagen, damage of elastin. So fibroblasts, those cells that produce elastin and collagen, they slow down the production of those proteins, and that leads to your skin loses elasticity and it causes wrinkles, right? And also, it doesn't show over here, but this subcutaneous fat layer also became thinner, and right, the whole dermis became thinner, and epidermis I actually can get even thicker epidermis, but dermis, this part became thinner. Okay, so I think this was our last slide, right? So I want to remind you that we covered the integumentary system. Thank you for watching, and I hope it was helpful.